Hello, this is a video regarding the FSM diagrams tool. Here we have a control block for a solder machine. It receives coins as well as the TOT register state to deliver a soldered someone. It also receives if the sum of the coins, the value of the coins is less than of the TOT register to do that. But what we want is to implement this block using the tool in VHDL. Let me make it small. First, we add a name to our diagram. So we can add FSM control states. Now, we can add the states. We have 4 states. 1, 2, 3, 4. 4, 4. We add the name of the states. The next one is sum, and we have deleted. Now we can make the connections. And this one goes back here. And this one goes here. So we have all the connections. We go from start to wait, to sum or deliver, from deliver to start, and sum to wait. Now that we have all the states, we can add the variables that are the inputs, coins, and the total less than sum. Okay, now we can make the transitions, the logic of the transitions. So the first logic is A. The caps A means that it is a 1. It will transition in a 1. If A is equal to 1, it will transition. The next one is C, which is A, and the B. When both are 0, it will transition to this one, which is deliver. And we have a final transition, which is else. It will be waiting for a coin indefinitely. Now, the sum transition doesn't have a logic, so we can let this open. The start also don't have one, and the deliver also don't have one. So open, no expressions for it. The next thing we can do is add the outputs for each stage. I will create one and then copy the rest. This one is for start. So we have here the SD receiving 0, which is the output that indicates it is delivering the solder. So we have the SD, the TOT underline here, and the load. It's clear. And the load. LV. Now we can just copy this state for we underline C. The clear here will be 1. The weight underline C with the coin will be all zeros. The next one, which is the sum, will be the load. We will add one, we will load the register with the coin. And then the next one, the deliver stage. Which will have only the SD, indicating that it will be delivering the solver. Well, here we have our diagram. Now we can just save the diagram. We'll open a box for saving diagrams. Let me save in this file. Save. Okay. Here we have the diagram. It is just a JSON file. I will put it in the tool. Let me just pause. Okay, now we can go back to the first tool, which we have here the button for the FSM generation. I can copy my diagram to the folder of the tool, the diagrams folder for the tool. Have it here. Let me just open the component files folder. I already done this many times, but I just exclude these two files. I can just press the button and open my diagram, which will be somewhere here. Found it. This is the diagram and generation complete. It will not analyze the file for me using HDL. And if we go back here, we have a new file with our state machine. Here we have start, wait, see, sum, deliver, and the outputs. With this, we can simulate the file. Let me open the Vivado tool. I opened Vivado and I already have a test bench for it. Let me just show that I'm using the file that I created, and we run the simulation. Here we have our simulation. It comes from, let me show the test bench. Have a clock, a reset. The coin comes in 60 nanoseconds. And we simulate that the TOT is less than sum after 80 nanoseconds. So here we have the start. It comes from the reset. Here we have the reset. From the reset, the start plus the clear, plus the signal clear, the TOT clear up, and then goes to wait for a coin. We put a coin, which is this orange one, and it goes to sum. In sum, it will trigger the load, and when we have enough coins, the TOT will be less than sum. So we go to deliver, and then go back to start again and wait for another coin. And that's basically it. We did all the process, make this finite state machine. And thank you for your attention.